And yes, you can get a whole room here.
Hi, Keithan. Kiki Palmer. Yeah, I love Kiki Palmer. She's so hot. How many Arnold Palmers have you had?
Oh,
7.
I've had a lot of Arnold.
Does anybody here watch Abbott Elementary?
No. I like Arnold.
Man, I had an Arnold Palmer while mini golfing. Best performance I ever had in my life.
Wait, Avery, do you watch Daily Girls?
Wait.
Yep.
All right, guys, let's go with it here. So 4.5, we got summary of perf sketching. We're going to put everything together we've learned so far in chapter 4. So here is a few things we're going to, and on the homework, it just says use the, let me just check here the search.
White is recording the meeting, and then Jimmy says some of these crazy things because, like, not like to actually see what's going on. That's what we should do.
It says use the guidelines in this section to sketch the curve. That's what we're doing. So we are going to learn. It's something we learned in Algebra 2. We've done this from Algebra 2 on. If you guys remember doing domain in Algebra 2?
Yeah.
Intercepts in Algebra 2. Intercepts, the y-intercept, you plug in zeros. With x, you got to figure out, sometimes you got to factor, you got to do some stuff to figure out where the intercepts are. Symmetry, something could be even, which is symmetry across the y-axis, or it could be odd, which is symmetry about the origin. And then sometimes you have no symmetry. Let's go. Asymptotes are things that make the denominator equal 0, right? So they break the graph. And then here's calculus now. So up until here, what we did is we did that in algebra. So we're doing 3 more steps here. We got to figure out when it's increasing, when it's decreasing. We got to figure out when we have local maximums, local minimums. And then we're going to go look at concavity and then points of inflection and then eventually sketch the graph of the curve. So this is
what the calculator have been doing those.
True, yes.
Not mine. Mine will take about 10 minutes.
So
Good choice.
let's go with it. Can you guys graph?
Oh, that's fine.
We go to here. There we go. Okay. So start off a little bit simpler here. We'll work our way through it here. So I got 2x squared. And then we'll learn stuff as we go along the way here. X squared minus 1. Okay. So we're going to use those little guidelines here each time to sort of think through what we have here.
I thought I was clever for this, since 3 of you are in this class, you'll be hearing this later just because I'm proud of it.
Mm-hmm.
You know the master virtues packet thing or the master virtues thing that you have to fill out for every day?
Oh, I need to
doing your
I need to do that.
I've done it every day. Maybe a day late, but you know I did it. It's called Master Virtues, right? And I was like, there's an opportunity here. So I named my copy Master of Virtues Moralica.
I don't get it.
Yeah, I'm not surprised.
Metallica.
I get
With Master Puppets by
Metallica.
Oh.
Now I've got to stick my hand.
All right, let's go with it. So we got domain on our hands here. So help me out here. This is from algebra 2. What can x not be, or else it breaks the function?
1 or 1.
Perfect. So x cannot equal 1 or -1. So you can write it like this. This is called inequality notation. You can write it interval notation, which is it works from negative infinity. Oops. It goes all the way up to -1. That's just fine. There's a break there. We go from -1 to 1. There's a break there, and we go from 1 to infinity. So both those, any of those would work just fine.
Okay.
The book writes both of them each time. But you don't have to write both of them. You can just write one of them. Next. Next is the intercepts. So the y-intercept is probably the easiest one to do. Y-intercept, all we do is we just plug in zeros for the x's.
0.
Perfect. So 0 goes on top here, and then we know what's going to happen at this point.
Watching these.
0 for -1, 0. And then we got ourselves the x-intercept. Now this one, not so fun. It's either y equals 0 or f of x equals 0. The 0 goes on the other side. So now we have this, and we have to solve for that.
All right, now we have to ask which of you guys have not seen the Goonies?
What?
I think that's
Have you
wrong.
seen Goonies?
Yeah,
What?
that's what
What did you say?
The Goonies?
Mhm.
You seen it?
No.
3,
Oh,
12.
Trevor did.
So go there. So cancel
Watched it
and
when I was
notice
6.
that. And then if we divide by 2 and do a square root of 0, it's still going to be 0. And we kind of already knew that already. Because if you plugged in the 0 for x, you got a 0 for y. So plug in a 0 for x. Notice you get a 0 for y. Plug in a 0 for y, you get a 0 for x. So that was it. Sometimes, though, you would have multiple x-intercepts, right? At most, you can only have one y-intercept. Okay, we're good there. So we know one point along the graph is 0, 0. We know there's breaks along the graph at negative 1 and 1. And then symmetry, I don't worry too much about symmetry. But just say it's a lot of work for not that much effort. But we can kind of take a look at just real quick here. If you were to plug in,
What was the x-intercept again? It was
0,
0.
and this one also was 0, 0.
0.
Now, sometimes on the x-intercepts, you might have 0, 0, but you also might have others as well. We good? You don't necessarily have to have 0, 0. Okay. And then C is symmetry. So here's what we do. We plug in. Now, let's see. I'm going to plug in.
This is what each problem is going to look like.
And we'll just do like 3 or 4 here. Plug in negative x into your function. And here's what we got here. As you plug in negative x into your function, if you get out x itself, we got ourselves
Even or odd.
Symmetry.
Even
symmetry
about the x.
about the y-axis. And we call this an even function.
Well, I think it's important.
And then if we plug in a negative into the x, it would get the exact opposite of our function. We have symmetry about the origin. And we call it an odd function. Okay, and then there's also something called neither. If none of those two work out, then we got ourselves neither. And usually symmetry is kind of made more like for just a check at the end. Like, oh, do I have symmetry? Yep, that's the symmetry I expect it to have. So let's do this here. Let's plug in. We're going to plug in a negative x into this little guy. A negative x here. And that. And what do you guys get? Negative squared is just a positive x. So we're good there? Boom. And we get the same exact function we started with. We good? What? So now we have an even function in our hands.
Every squared would be x.
Oh, yes. Thank you so much. Thank you, Weston. Even functions. So that means we have symmetry. When we do this here, we're looking for symmetry about the y-axis. Cool. All right. Done. D. We got ourselves asymptotes. So tell me if I'm going too fast. I can go back. Yep.
Even, so negative equals positive. That means negative equals, yes, fine. Even.
Okay. All right. And we're gonna a few here.
Did you know that they made a woolly mammoth meatball? They just made like a giant amalgamation of genetically produced mammoth meat, and then a millionaire ate it.
You know that they actually
Okay.
remade the mammoth?
Fully, they
They just used an elephant.
they
My
made a
grandfather actually tried mammoth steaks.
they made a it was an elephant it was
Wow.
like an
He was
elephant.
not rich.
It They did like an elephant hybrid where they implanted mammoth DNA into a elephant egg,
Mm-hmm.
and they just made a really hairy elephant.
But some of the DNA did not take. Okay. Okay, asymptotes. Here it is. What we want to do is we want to put our function in lowest.
Oh yeah, they don't feel it. I swear that's in Japanese. There's something
lowest
oh,
term.
yeah, you eat the no, there's a certain thing. You eat the shell of it. You eat its tail. You cut off. No, this is shrimp. Cut off the tail. You eat the tail. Then you kill while the shrimp is cooking right there, and it sees you eat its tail.
Oh, yuck.
It's all in the ball.
All right. So for asymptotes, we always have to put our function to lowest terms. If anything cancels, if you guys remember from algebra,
No amount of money could.
$200.
No, I would not do that.
What do you need me to eat?
$1,000.
It would be a billion dollars.
I should probably stop talking so
Okay.
it raises it more.
So there you go.
What do you need me to eat?
I'm trying to
So
learn
real
my
quick here.
I'm trying to make money.
If it cancels, if something cancels, that means we have something called a hole from algebra 2. You guys remember those? If it doesn't cancel, we have ourselves asymptotes. Right, so let's write down here real quick. If it cancels,
We're just going through everything.
yes, this is it. We have ourselves something called a hole, and it's when you graph your line, all you do is you put like this right here. You put a little hole in your graph. If it does not cancel, depends how sheet of paper goes. Okay, if it doesn't cancel, then we got ourselves our asymptotes. So in this case right here, we have an asymptote. There's 2 of them. Asymptote x is equal to 1. And then I'm going to do like this here. X is equal to -1. The reason why I don't just write it as x is equal to 1 comma -1 is because these guys are actually lines, right? They're vertical lines going straight down. So x equals 1 is a vertical line. And x equals -1 is a vertical line.
So just factoring.
Factoring,
So when we factor, and if it doesn't cancel out,
Then
then
they're
it's an asymptote.
asymptotes. Yeah. And so now notice.
Oh, I remember this.
Cool, yep, It should ring a bell there, yep.
Rings a bell. It's just I don't know where the
Vision when it's find A, B, C, D, E, F, G. All
And sketch.
What if since this was basically all of 4, you
I
just
don't
gave
think-
us like 3 of these problems?
No.
That's kind of sort of what we do. Except remember L'Hopital's rule? There's
Oh, yeah.
those
We
pieces
can do
there
that.
and
Yes.
kind of stuff like that, yeah. So yeah, remember 4-5 is the culmination of everything we studied in chapter 4, right? Everything is culminating right
Your
here.
test is
So
one.
increasing.
That would just give us like 1 of these.
This is more like
No, but-
And then
4 of these.
Put
yeah.
L'Hopital's rule into it somehow.
Okay.
That would be
Think
like
about
your,
it.
Slightly confused. How do we know the asymptote is 1 and x equals 1? Oh, because they're as well.
Yeah, still has a problem. So notice real quick here. So, Wes, I'll get to you in just a second here. So notice real quick here, as you factor this out, sometimes the asymptotes are going to be exactly like your domain, right? Your domain here was,
Is there a
could not be 1 and 1 negative 1. And there's our issues right here. So domain is either going to go into a hole, we good, or is going to go into an asymptote, right? It has 2 different ways it can go, just depending on. So we just have a question.
It's an asymptote and not a hole.
Weston, go ahead, and then I'll go to Eli.
So how do we know which direction the line goes?
It
in the
depends.
axis?
so like if we factor the
Yeah, that's what we got to do, increasing, decreasing, and see what's happening.
like x plus 1 is
Isn't there a way to do that without
cancelled out, that would be a
calculus? If
whole.
we do that with like,
negative.
Yeah, you could take a look at just ratios as you get close to a number, more like an intuitive
Wasn't
approach.
there a non-intuitive, non-calculative approach that was
What did you just say?
non-calculative?
Those were for horizontal isotopes or oblique isotopes. Yeah, but not for vertical isotopes. Okay,
Stop it.
so I got asymptotes done. Next on the list is, anybody help me out here? Next on the list is
E.
increasing, decreasing. Okay,
Yes, after
E.
T is E. You are correct.
so I have increasing, decreasing. Here we go. I think what we have to do is, don't we have to do this? We have to set it equal to, oh no, we got to take the derivative and we set the derivative equal to 0. I remember that. So we got ourselves a quotient rule in these guys. Oh, okay. Help me out here as we go. So what's the quotient rule?
I couldn't tell
G prime minus E prime F
I thought it was.
Sorry, not
over
product
G
rule.
squared.
So here's my little quick way of writing it. F divided by G prime is F. Just check it out here. FG prime minus
F G of prime
G of prime
G squared.
G squared. Okay, that is it for sure, for sure.
Yep, that's
All right, let's go. So 2x squared. Yes, you did. 2x squared, that's F. The derivative of G is 2x minus. G is x squared minus 1, and the derivative of F is 4x all over. Boom, boom, squared. Okay, let's simplify this out as much as we can. So I got myself a 4x cubed minus, okay, so see if we can do this here. I'm going to multiply the 4x into here and then also think about it being a negative here. So 4x times x cubed would be 4x cubed minus
plus
4x times 1 will give me a plus 4x all over what I had before. And then simplified version is, oh, nice. That is a simplified version. Okay, boom.
You know, the probable body that's actually fit with your brain. You just think that you can fill your hands with it.
It's not entirely with you.
And then we set it equal to 0.
I was waiting for someone to correct something on there. That's all.
No, it's wrong.
Right.
God, jeez.
Aw, there's a quick way to do it.
Negative.
Starting over.
Give me a sec, give me a sec.
If we x squared minus 1 and then with the x squared minus.
It's a quick fix.
Quick fix. Quick.
Do we have flex tape?
Stop looking at me, I'm trying to focus.
I'm sorry, I was confused by the sound effects.
4x.
It's like a train.
Oh, you're the one over here saying food.
Stop that.
Want to tell us where it is? Is it like in the beginning or toward the end?
Way in the beginning.
Way in the
Absolutely.
beginning. Oh,
Way in the
That's
beginning.
great.
Could we take the x squared? No.
2x minus. No, the
We could
derivatives are
cancel out the
right.
x. No, my mom can't.
Oh wait, no.
4x cubed. And that's 4 minus 1. No.
Wait a minute.
No,
shouldn't-
that's right. It's minus 4x.
Where's the 4?
You
The 4?
you have a no, you don't, because you have a
it's multiplied by
minus
negative one.
of 4. A minus of 4x is a plus 4x.
Yeah.
What the heck?
What?
Wait, it's something right there. Something's doing this wrong.
Just point at the entire thing.
It's something on the screen.
I'm slide 1.
This was that scene from How to Train Your Dragon.
Keep-
You just want to fix that.
Yeah.
Just pointed at all of me.
Just
Exactly.
No, they want
Such
I wonder-
fantastic
It's so good.
And then it's 4x is like 2 times 2, like
That
x.
gave us.
I'm looking through all of it and it looks good to me, but apparently it's not.
Maybe there's nothing wrong. This is just a test.
And he just wants us to really study this.
But
I would
actually,
do that. That would be
you.
That would be.
That's kind of smart though.
I'm actually so lost.
I have no
Where
idea.
did the negative 1 go?
It was multiplied into the 4x.
I like
So could we take
where you're
the
going
x
with that
squared
though.
minus 1 at the bottom? Oh, could we just take 4x out of everything? No, we could divide by everything.
Is it like an actual mistake or is it something that you did that you didn't have to?
Actual mistake. Yeah. Stated in class. Mistake was stated in class.
A mistake.
But,
I don't get it.
Alright, so you take the 2.
Is it obvious?
Yeah.
Yeah.
Oh, wait. No.
This is so. Eight of us and none of us know.
2x squared will be 4x.
You keep the 2x squared, the square root of x squared minus 1.
It's in the It's in that
2x.
first initial line.
You minus, you keep it minus
Wait,
1.
how's that?
It's in the
X
initial line.
minus 2x.
Should there
How's
be
that
a...
4x?
Oh, wait.
Just waiting.
2 times 2 is 4.
And then x squared plus x is x.
Is x cubed.
We're
But then
so
the next
lost, we had to
one-
go back to
the next one
first grade math.
X
2
cubed
times 2 is 4, correct?
Squared.
minus
And then
4x, but then it's minus the whole thing.
Oh, there's a negative sign. It's 4x cubed minus 4x. Because the 4x into the x squared.
I said
and the
that and
4x
you told me it was
4x
wrong.
cubed, wait, it should...
No,
Because
that's
it says minus the-
No,
I'm
4x
minus-
cubed times negative
So-
x squared is in fact going to be 4x
4x
squared
squared
or
minus
cubed.
4x squared minus 4x.
Oh, because we multiplied here. That's a negative 4x, right? Negative 4x, and then we got the negative here. It
Oh, you're right.
Plus 4x. So then it has to be after that.
No, it's in the beginning.
No.
was before that.
It's before that?
It is the first line.
Did we-
What in the
Right.
world?
The quotient rule wrong.
Should there be
Lucy is correct.
Oh. Get it, Lucy.
What did Lucy say?
We wrote the quotient rule wrong.
Negative.
What's really important.
Okay.
Should it be x?
Is it
G?
Stay up there, quotient rule.
It's in my second
Again.
which means I did
It was funny. I had no idea. I just was like guessing which one was negative.
Is it G? Is it the derivative
It's
of
probably.
G times
G?
X?
It's
Is it
G x f prime x.
Oh,
Is it G
F
prime F
prime.
minus F
Oh,
prime
you
G?
can't do this.
it's
So just
G in
make one
front,
plus
right?
and make one
Oh,
negative.
okay.
and then the
Right,
derivative
that's
is
wrong.
for that guy.
Yeah.
Very good.
And then
And then the
minus-
derivative is
Oh, and it does matter because it's not
So all we have to
That
do is
one.
switch the negatives.
G.
Oh,
So it's
shucks.
negative 4x over x squared minus 1 squared.
Okay, so we have to switch this part here. We good? Should go over here, and this part should go in front, right? We're switching the
Change
two
negative sign
parts.
to a positive sign.
One second here.
Change the negative.
So then if you switch those, so the only difference would be a minus sign right here. We good? Yeah, so it's the opposite. So, but don't forget, like this would be totally wrong, right? Just, so that was wrong. That was wrong, but the only switch that needs to be made is a negative 4x. We're good?
Keaton's gonna be watching this. He's just gonna skip the past like 5 minutes and we're trying to find the mistake. You better not have skipped Keaton.
Now we've.
She should say.
Okay.
Watch it and be like yelling at the screen.
Okay. Wait. John,
No,
we go back.
we can basically.
Pretend like we're so confused. But he hopefully skips over the part where you got the answer and say,
Wow,
"Well, I
that's
guess
cringe
I'll
that you
leave
just said
all
that
on
during the
solved."
recording.
And erase the recording.
It would be so great.
That would.
No, just skips over the part where you get it correct. And
Uh-huh.
just think we never saw
Like, where did the negative come from? Yeah, forever. Okay, so here we go. So we got to think about my domain for my derivative function, right? What's my domain?
It's gonna be 0 or 1.
Yes, okay, it's the same as our function itself, right? So at that point, there's a break in my function, there's a break in my... Oh, sorry, real quick here. Maybe this would be better here. So with that, we're going to just multiply by the denominator. Here, denominator here, and anything times 0 is still 0. So we have ourselves x equals 0 does something. There's a change from increasing, decreasing. So we're going to plot it back into my derivative function. And all we need to know is there a sign change, right? Remember, plugging them back in my derivative function, which is this one here. And all I want to know is, all I want to know is positive or negative. Cool. Okay. And so think about this right here. Think about this right. If you square something, does the sign change?
9.
Yes.
Depends.
-1 times -1 is positive.
Oh, square something? No.
Yes.
Well, if you square, well,
crazy?
if you square something,
If you swear.
If you cube it, no. If you
A
do,
-1 times -1 is a +1.
wait, no, yeah, like, sorry, I meant like,
if it's an odd power,
If you
then it
square
does
it,
not
if you
change. If it's an even
square it,
power,
if you square a negative number, the sign will change.
If you
Yeah.
square a positive number, it doesn't.
Yeah.
Cool. Okay, so if I plug in a negative 20 into here, if I square it, right, it becomes positive, right? And then if I square it again, notice I'm squaring it again right here. So notice even with that, this whole entire denominator is going to be positive no matter what. Are we good there with that? If you're squaring something here. So really, I don't care what happens on the bottom. I just care about right here. We're good there? So if I plug in a negative number into here, if I plug in a negative 1, it'll be positive. If I plug in a positive, negative t, it will be negative. Are we good there? So I got myself increasing, decreasing. Where is it at? Increasing is from
negative
Infinity
zero
to zero.
0 to infinity because there is no negative one.
Negative 0.
I'm so sorry. I'm like so confused what that is. That like chart thing, the positive and negative. And like
why do we do it?
yeah.
Yep.
What that
So first things first, it's not the original function, it's the derivative function.
yeah.
We don't care what number we're going to get out of it. We just care about the sign that we're going to get out of it.
Shit.
Any positive signs, that means our graph is going up. It is increasing. Any negative signs, that means our graph is going down. We are decreasing. And then we know, and then also if it switches from positive and we know it's hit 0. Real quick here, we should actually do this here. And then of course there's like fun little things here.
Miss one folded. But then again,
I'm messing with you guys just a little bit here. I don't know. It's like a mess up with you guys' day. So notice I just said I didn't care what the bottom was, right? But if you're to plug in a negative 1 into this little guy right here, what do you get?
0.
if I forgot,
Undefined. So hold on. What?
there's
What?
But if you put in something else below that, then it'll be.
Does that mean those are
What did we talk about in the way beginning part of this slide here? What did we do? What was the first thing we did?
Nope.
We talked about starts with D, ends in main.
Domain.
Domain. So hold on. We got a 0 here, right? Oh, bummer. Writing in pen. Here's our little problem.
No.
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 So
Well, it's my own fault.
here's our little problem. We'll fix it in just a second here.
It'd be negative infinity to negative 1 and then
At-
negative 1
At
to
negative 1, that we had what? We had breaks in our graphs. We had breaks on our graph at 1. We good? No. So you can just scratch it out. Just scratch it out just a little bit. So it's not only where it hits the 0. It hits the 0 would be these dots right here, right? But you also have to think about when there's break in your domain. We good? So you had slashes there. You could now just do those things. We good? Purposefully, I put in a negative 1 and 1.
Could you have a hole in the graph, the second derivative? Would that transfer over to the first derivative in the original graph?
I'm thinking here, how do holes work here? Usually, I've never seen that happen. It'd be interesting to ask your dad, but I've never seen that happen where it converts into a hole. It's possible, right? Just because the numbers work out that way. So real quick here, guys, real quick here. So make sure you're thinking about your domain when you do this. Now what we do is we go and
F.
we have 4
Local
things
minimum
to
and
test.
local maximum. So we don't have a local minimum, but we do have a local maximum.
Whoa, let's see. So as we plug in numbers, we can't plug in a 1 or a negative 1 because it's not inside of my domain. We good? So we got to plug in something else. A negative 2 would work just fine. Is the bottom also going to be positive no matter what, though?
Yeah.
Right? So it's going to be, oh, hold on. So if we got a negative 2 here, negative 2 is still going to be positive. True, true? Okay. And then over here, between negative 1 and 0, if I plug in a negative 1/2, will it still be positive? Oh, no change to what we had written before. Are we good? Okay, and then if I plug in something positive, positive 1/2 times a negative 4 would give you
Negative.
a negative number. And if we plug in something after, like a 2, makes a negative 8, And we got ourselves that right there. So no need to erase anything on your end drawings. Are we good?
And the local
I was
maps would
being
be-
nice. I was being nice. But
Fine, I
be
forgive
careful.
you.
Be careful with your domain and your zeros. We got a constant for both. Question.
No, it's just, I did something to my account for some reason.
Okay. So now the only thing we do have to change just a little bit here. So it is increasing, and I'm not sure. Let me just check real quick here. Because there's a break in our graph, right?
Isn't it increasing
So
from
we-
negative to positive? Or increasing from
Oh,
negative.
I wrote it wrong
Yeah.
as I was trying to mess around with you guys here, right? So
So you.
I did mess up. I messed up actually. I didn't even.
I need whiteout.
No, you just need better handwriting, so it looks actually worse handwriting. My bad. Yeah.
Or maybe you just need to not write in pen.
So did you change your nails again?
Maybe you need to stop.
I like them.
Thank you. I got them done for senior.
I wonder what times.
Oh,
I got them.
Keep them
Can you see them?
That's all.
During
Doubles.
I'm actually obsessed. She did such a
Can you see
Triple speed, yep.
Yeah.
So class real quick here. I messed up
he
it.
was worried.
So you are going to cross something out here. Real quick here. You're going to cross this out because I did mess up.
like this.
And this right here. Because I did it the opposite way. So we go increasing. Increasing is from negative infinity. And you're going to go only up to -1. We good? Increasing is from negative infinity to -1, comma. Because we have a break in our graph. Then it's increasing from -1 to 0.
Those tacos are what? Sorry.
Decreasing. Decreasing is from 0 to 1. And from 1 to infinity. We got to think about the break in the graphs. That one I messed up on. Sorry, guys.
I'm sorry.
Now
That happens. Mistakes happen. Sometimes it's in pen, sometimes it's erasable like that. So we will
Sometimes we invest in whiteout.
Esther is very annoyed right now, but that's stuff happens.
What's more with the pen?
Oh, I know very well what I'm doing. I am well aware of those.
So we got that. We got that taken care of. That is E. So let's go on to the next one. Next one is
F.
F.
good. What is F
Local,
about?
max, and min.
The local max will be at 0, 0.
Perfect. So local max.
You know those like that's the pyramid you're gonna do, right? Make like say the alphabet backwards. Who knows?
Y X W
I love that
V
you put it. I would have to think about that
So
so.
V U T S R Q
I
E
Z and that's
O
it.
N M
Dang.
L K J I H G F E D C.
V-Y.
I'm not gonna try now. How about that?
V-Y.
X.
I'm special,
W.
Weston.
Okay.
X.
We got ourselves
Are
local
you
max.
This is a test, not a drunk driving. Under the influence test, God.
Y. W. Question mark.
No, I have a
You?
great comment.
V Y X W. No, V U W.
That goes to police.
Strong. I can't say the alphabet.
Wait, how do they say
No,
it
I have a
now?
great
The
comment
only
that shows
real
a police
test
car
for like
pulling
your drunk
over
driving
either the
capabilities
driver or
is
the
just for
dog
copy getting
because
hard.
according
So
to
stupid. What do you
the
mean?
breathalyzer, you will be drinking from the toilet.
Oh yeah.
That's why. Yeah.
It comes to dog.
No, that's nasty. That's a stupid joke. It's nasty.
Ethan, we're just taking a break.
Odd.
Sorry.
And he said that like because he has friends who are close to firefighter goes, yeah, they actually.
Anyways, don't do
backwards,
drugs,
so when,
kids.
like, any driver says this is stupid, no one's gonna sober. They can just
They
like
can
say the
randomly.
alphabet backwards. It's like actually the police
Me
person is saying the alphabet backwards. It's so stupid.
Yeah, I could see counting backwards.
That's
That's
mean
that's
as
big, but not.
Counting backwards from what number?
W? That's
You
what we
can't
thought.
count backwards because
Just say
you
that
don't
with
have a place
confidence,
to
and then be
start.
like, do you want to know more?
I count backwards
And
from
you'll be like, no,
100.
that's okay.
Oh, there we go.
I'd like
99,
to, I didn't
92,
know
one.
more. And I am drunk.
What's funny?
Well, what do you mean? I can't even do that sober.
Okay, class, let's go with it. So we have a local maximum because it goes up and then comes back down. We have a local maximum at 0, so then we are gonna have to plug it back into the original equation, right? But we're gonna know 0 is 0 because it was already our intercept, right? It was already our intercept earlier on, right? So 2, 0 squared All right, there is our 0. G, concavity. We have to take a second derivative. I need to know this guy here.
After one.
Second, so let's do.
Wrong again.
Yeah, let's do our first. Oh man, this is our first derivative. Just before we get started here. And now we're gonna go to the second derivative. Let's make sure that we get our quotient rule correct here.
Oh man.
So this guy,
GF prime,
GF prime
F prime G.
minus
No,
F
F G
prime
prime.
G.
Is it F prime? No, it's GF F G prime.
No idea.
F prime G. Gosh.
Right? So it's still in order, right? The derivatives are still in order. I'm not sure why they write it like that, because to me it makes sense just to write F prime G minus F G prime, right? They're both written the same, but I was not the author of the textbook. So let's go with it. Can you guys do the quotient rule? Go for it.
What textbook did you
It'll be
swallow?
X squared.
Sorry. Quote. I'm not being rude to you. I'm really sorry. It's from Divergent.
Oh my gosh, yeah. When he was
Christina
talking about like
asks Will, and then she kills him. She killed Will. She
wait,
didn't.
what scene is
This
I
went from 0 to
Negative
60 real fast.
this? What scene is
Nine.
When
The second
when she has to
Two,
kill
like-
Will.
It's just nerdy talking about what textbook you saw in.
Oh yeah.
4 and
Oh, no
way.
You're fine.
You're from area dynamics.
Yeah, when they're eating their first
Oh,
lunch.
I said this.
She's like,
Right,
what textbook did you swallow?
Okay, you guys, tell me real quick here. I did it, but just
Squared minus
make sure that I did it correctly here. Any
You never
issues
know.
here? Because I could be.
Weird minus 4.
Should be.
Have you ever seen those videos like during summer? The topic I saw this after drink. It's like tangent or like tanning.
Is that a 2 or a square?
Yeah, it's a 2 because it's the second
right.
derivative from that, which he put in front. We get 2x. Why is it 2x?
Thank you.
Oh yeah, the 2x squared and then got the 2x from. Yeah, yeah.
So
That looks good.
4.
This is
I think-
insanely long problem.
No, it gets longer. Be thankful for this.
I'm already done. Like,
Okay, this is
I'm at rule
plus-
number 8 now. You know what I mean?
Oh, that's
Is that
what
the
we
given
got.
out?
7.
Darn it, I'm at rule number
This
7 already.
is let's see, 2x.
Rule number
That's
8 would
4. Is that right? You guys help me. So it's a
Yeah.
2x. That's 4x.
X.
So 16x squared
Four. 6x to the 4.
Yes.
to the fourth. Where's the fourth? Oh no.
Squared plus
Yeah,
2x.
before I multiplied in here. So I got 16x squared
At least on my
multiplying
dial.
now and x squared minus 1, right?
Yeah,
And this is x squared minus 1 to the 4th power.
Tweaking.
It's called
Boom.
tweaking.
Okay, so real quick here, as you guys take a second derivative off of polynomial functions or quotient rules here, notice you are going to have the x squared minus 1 in there somewhere. Because remember, you took a derivative of it, you let it stay the same here, right? But then you took a derivative here. So notice you have an x squared minus 1
Oh,
just sort of sitting there.
Cancel them out.
Absolutely.
Yeah,
So what we're going to do,
I have a
we're going to cancel, yep.
Like, not on this.
Well, we just do
So,
it
like,
out.
this
and
is
we
like
pick
how it's
one.
gonna be on the test. Like these
Wait,
exact
which-
ones.
No, not
How
these
many
exact
these
ones.
It's take us 45 minutes.
Uh-huh.
Like, this one.
Easier when there's
So
Well,
how
we're
many
gonna once we do it, yeah, we're gonna be.
test when it takes.
We're gonna actually be doing it.
My guess is
Yes,
it'll be
what
like
Weston
a
said.
question
You'll just
test.
Alright, so
Something
yes,
like
we can
that,
take-
yeah.
And it'll be like
should-
one with
There'll be
the
3,
else
and there's gonna
will-
be the.
Would it be like
and one
are
more.
they worth more than like, or is it still like gonna be only?
Sophie, we'll
like
get
four
there when we
questions?
get there, but at
So
the
you get
moment, we're
one
gonna
for
have
all
0 if we don't actually do
How
it.
about step by step?
So like every step it like is out of 5.
Out of 2 points or something like that, yeah.
Okay, so it's not gonna be like you missed one part and then it's like you.
Black
You're
square
done.
with the
Zero.
domain.
Darn.
Like this, they're on you.
You
What?
messed up the symmetry.
Exactly. You failed it.
I would
Go
rather-
back to kindergarten.
Sorry.
Yeah, I did calculus in kindergarten.
Uh-oh.
She understands.
So we're going to cancel one of the x squared minus 1s, right? That is normally going to happen.
Couldn't we factor the x squared minus 1s out of the top and then cancel it?
Yes,
Get rid of more than one.
No, you're still going to get rid of only one because this guy here only has 1 right here.
Okay, this one.
In the sense of the.
Okay.
Okay, got it.
Good. Okay, so now I got one of these gone. So -4. I have -4. Multiplying one of them now, I believe. Let me just check here. One of them. and then plus 16x. Now I don't have to distribute.
Shouldn't it be a 16x squared?
16x squared. And I don't have to distribute, and I only have 3 of those guys on the bottom.
We could probably factor out the top.
We can simplify the top now. Okay.
We both motioned at the same time.
Negative 4x squared plus 4 plus 16x squared.
Do you need a pen, Weston? Sorry, that was rude.
Oh, that's warranted, I'm gonna be honest.
Maybe don't write on pens.
We remember we
Great power comes great.
Okay, well, I'm explaining for Keithan in case he doesn't understand.
Ethan was paying more attention than we are.
No, he's not. He's
We
falling
all
asleep.
probably sound like mice because
We all know Ethan's falling asleep right now.
Mice.
No, because when you shut on 8 times speed, your voice definitely high.
Oh, we better tell him to watch this whole thing.
This is peak comedy. Like, he doesn't need to stay a comedian anymore. He has to six months.
Let's go with it. Can you guys give me concavity? Tell me when it is concave up, concave down.
No, but like a really high like chipmunk
So
speed.
it'll be at 1 and -1 when it don't exist. So where it's positive and negative at those points.
Okay, cool. Yeah. So just let me set it equal to 0. We good first? Got a few people still writing it up. So 12x squared plus 4.
No, you don't.
No, he's writing down the thing that you need.
No, I was on the second one.
You don't need the second one, you got the
second one?
last one.
I'm on
That's the one we're using.
negative x 4x
Lucy,
squared
is that
plus
07 or
4 plus
05?
16x squared.
Over x squared minus 1 in
07
parentheses.
or 05?
X squared minus
Is
1.
what?
Cubed.
Cubed.
And then I did the other one.
And then you get the
07.
Why?
he put
Why?
it back.
They're better than 05s.
Really? Oh yeah.
I only have 05 though.
He did.
I like
They
school.
were
He
wrong.
distracted me with
I
pencil at me.
I normally get 0.
I just find whatever I find.
I knew
in
you
the,
would.
Okay.
I felt like
Set it equals to 0. My domain.
no, mostly you're in
Well,
the loft of no one else is playing.
Are we good with that? 1 and -1 is gone, and let's finish up in 10 minutes.
Let's
1 and -1 is a problem. So that's my domain error. So now I'm going to multiply both sides by my denominator, and which will just make my denominator go away completely, still set equal to 0. All right, let's see.
This is the cheapest thing ever. You know what? Instead of
So it's
removing it, we're just gonna cut it out, divide it by 0. Who cares?
So let's see.
Steal square root of 3.
Ooh, hold on. So if we subtract 4,
It's
divide by 12. So we got ourselves x squared is equal to a -1/3. Is that right?
and then you find the square root.
And we take a square root of a negative number, which
You don't want.
does not exist. Or
Good.
no solution. Is that right?
I over 1 over I over square root of 3.
So there's no concave.
All of that was for nothing.
Cool. So no solution is
What's the
awesome.
graph
No
look like?
solution. Get there in just a second here.
Very
Okay.
interesting.
That is so perfect. So now the question is, do we need to check anything?
No.
No.
I mean, you don't need to find points of
Probably.
inflection because there's no point for a twin. There's no
Huh,
inflection.
that's so fun. So let me ask the same question again, and you guys answered the exact other way. Do we need to check something?
Yeah.
Yes. We have 3 sides to check. We actually have 3
That's an
sides to
absolute
check.
fact.
From the top to the middle.
We have to check. I don't know.
Oh yeah, on either side of the
0, -1, and nope.
No, -2.
One, zero.
Where are my breaks in my graph?
Negative.
-1 and 1.
Yes, -1 is my breaking. There's no 0. There's no dot I circle to give me a 0 for my second derivative, but there's still my domain issue. That's why I put this up here. So I still have domain issues where concavity can change because my graph has broke at 1 and -1. So I'm not sure if concavity has been different there. So let's plug in -2 into my original or my let's see how to say this here. It is my second derivative function. So think about what's going to happen here as you plug in to the third power. Okay, so through the third power here. So -2 plugged in. So notice on the top here, if I square something, positive. If I multiply by 12, and if I add 4 to it, who cares about the top? We good? So now,
bottom.
so on the bottom, now on the bottom, if I plug in a -2,
Positive.
Positive.
4 minus 1,
3.
3 and squared. Or so cubed now, right?
Still positive.
Still positive. Okay. But then what happens between -1 and 1?
0.
You can plug in a 0 to test 0. 0 plugged in, -1. Oh, now we're cubing stuff. Since we're cubing stuff, we got ourselves
A negative.
a negative here. So this is negative. This is concave down.
Positive.
Across here.
Because it's a
And
2.
2, it's a positive. So there's our stuff there. Whew. I think we're ready for just sketching this. Oh, hold on. So concave up. So C, I don't know. Should we just say C up?
Is this
Concave up is, yeah, this is G.
Cup and Q.
Is from -infinity to -1, and then from 1 to positive infinity.
The graph. is
Concave D was, how should you, DN? CDN? Concave down?
It was just
Maybe CD.
CU and CD.
CD.
in the
CD?
book.
Okay.
From
CD.
-1
What do you think it should be,
to
Q then?
+1.
He's asleep.
Oh, yeah.
So from -1 to 1 is concave down. We good? Okay. So in the book, there it just says CU. Is that what it does?
CU and CD.
Oh, gotcha. Okay, which is kind of interesting. Okay.
I like.
CU. I like the cup, but I couldn't. Bless you. Couldn't.
What?
Okay, so let's put this
He says
finally all
pursue for
together
any
here.
reason
So
you can
let's
find.
go here. So let's do this here. We're gonna put our graph here. And if you want, let's see, in
C
the
down.
older days, so let's see what we got here. We got 1, we got ourselves a dash coming down like this, right? And that's -1. And then a +1, we got ourselves this coming down as well. What else do we know? We know we have a 0, 0 point right here, right? It is our intercept and is the only intercept we have, right? And it's also a local max or local min. Which one is it?
Which one?
Get local map.
Local
So
max.
local max, right? It goes plus, 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 and turns to a minus, 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 right?
And it's concave up.
Cool. Okay. So if you want to, I'm going to rewrite it over here, but you probably should look at your notes, right? Because I just don't have it in front of me here. So if you want to take a look at your first derivative and your second derivative, this is a good way to do it. Or if you can kind of keep in your head, like I'm going concave up, concave down, all those things, right? So let me just redraw these just real quick here and have to help me out here. Can you guys tell me for the first derivative? We had this right here, right? Give me plus, plus, or minus, minus. What was it over here?
It was plus, plus,
Plus here, was right?
plus.
Minus, minus. Tell me real quick. Is that true right there? For the second derivative test, what do we have?
We had plus, 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 minus, minus, minus. Plus, plus.
Okay. And we had that. Okay. So now we're going to put this all together based upon that right quick. So remember vertical asymptotes, you can't touch vertical asymptotes. Has to do something other. Notice also we never touch the x-axis ever except for this little 1 point right here. We're good? So now let's go with it. I need a graph that is going up. It's increasing. It's concave down. I'm sorry, concave up. Sorry, concave up. And it never touches the vertical asymptote here. It never touches the x-axis either. And I got myself, I think Esther's saying it correctly here. Boom, like that. Is that right? Boom.
Yeah, exactly.
Then we have, it's climbing up, but it's concave down. It hits a local maximum. Then it goes down and it's concave down. What does that look like? Yep, it's climbing up hits the top, climbs back down. It is concave down all the way through, right? Weston,
So
question.
in the test, if we can figure out the graph like before, like we've done like half of the steps, and because of that we realize we don't have to do the rest of the steps. Do we have to?
Ah, bummer, because the test is gonna have give me points per section.
Oh,
Yeah. So
Look at it this way though, if you find what the graph looks like, you can check your answers.
That's true.
and go with it. Let's see. I need something going down forever, and it's concave up.
They're like,
It's decreasing, right? It's going down,
oh, be like,
but then has a concave up term. Yeah, and remember, make sure it doesn't have a local minimum, right? It can't have a local minimum. It can't go up anymore, right?
Straight line.
It has to keep on going down forever. And then it can go like this, but you should not write it as if it's going. Don't do that right there, like that, right? Right. It's not going up ever, right? And it's not touching the x-axis either. Okay, you all, are we good there? Yes. And
Welcome
the
to
whole
calculus.
entire class period.
That's pretty cool.
I'll be done with five.
We're
So-
done.
Weston, if you're what is the likelihood that he's going to be the only student to be in calculus next year?
What?
Will he be in calculus? Are you going to be in calculus next year?
Wasn't calculated.